You have to do something before the time. Okay, it has just gone 17:30 in Philadelphia, 21:30, I believe, in UTC. So it's time for us to start. This is the CBOR Working Group meeting at IETF 114. Welcome, everybody, and thank you all for coming. I had thought Christian was going to be on remotely, but I do not see him. I wonder if he got the time right, but in any case, it should all go well. So note the note well. You probably all know it by now many times, but this is your obligations with respect to intellectual property disclosure and compliance with the various BCPs. If you don't know it, learn it. Here's Christian. Hi, my co-chair is here. So everybody in the room is wearing a mask. Thank you. Each of you is wearing a mask, I should say. You're not all sharing the same one. Thank you for doing that. And I'm going to keep my mask on, even though the rules say I can take mine off. But if anybody in the room is coming up to this mic, which I don't think anyone is, but if you are, you're welcome to take it off. Otherwise, please use the magic code here and get on Meet Echo Lite if you are in the room. Please add yourself to the queue through that tool. If you can't scan this, you may get it from the meeting agenda. So, what we have for the agenda. I get 3 minutes, it says, and I have 1 left. We're going to go through status on the working group documents. We're going to talk about some upcoming work, CDDL, tag registry development and maintenance. And yes, so that's it for the agenda. Any agenda bashing to do? We all happy with the agenda? Thank you. Christian, I see your nice face now.
Yes, as I said on the chat, sorry for my delay, but I'm here now and jumping in whatever needed.
Great, and as you weren't on when I said this to the room, but the speakers in the room are facing everybody else, not me. So it's hard for me to understand what the people who are remote are saying. So if I look stupid, that's why. All right. Document status, we have RFC 9164, CBOR tags for IPv4 and IPv6 addresses and prefixes. That's been published thanks to the authors and the reviewers of that document. Yay. 9165, additional control operators for CDDL. Also published recently, well, not that recently anymore, so again, thanks to the authors and reviewers. File Magic is in the RFC editor queue. It finished IESG processing, and that's always excellent. Karsten, you have an update for time tags, so you're on.
Yeah, I actually have some slides in the big slide set that I made, so maybe we can do it at the.
Okay, we'll defer that to when we hit your slides.
Yeah.
Okay. Okay, and that's what we're about to do. So go ahead and request slide access. And
okay. Yeah, it's always a bit confusing to use this interface. Don't know what makes it so confusing. Anyway, so I want to talk about time tag, which we just mentioned. I want to talk about PACT. And I have one slide on 9254, which is not a CBOR working group result, but it has CBOR in the name, and it's maybe something that we should keep in mind in future work. And then at the end, I would like to talk about CDL evolution and maybe a little bit more about what 9165 means, and then the 2.0 roadmap, which obviously needs new dates from those that we discussed in IETF112. Okay, so the time tag document defines a tag for times. We already have two tags for times, 0 and 1. But these only have limited possibilities for attaching additional information. And tag 1001 has been registered to carry lots of additional information. And that has been around for a while, and it also has been registered for a while already, because at the time 1001 was actually a first come, first served space, so it was easy to register, and we just did it. And it's also in use in implementation, so it's not something we really should be changing a lot in the way of breaking it, but we still can extend it. And when we discussed this about a year ago, when we did the working group adoption, we said there's this new stuff going on, the sedate working group, and we wanted to wait for their considerations to become available. So they are taking the text form of internet timestamps, RFC 539, and adding hints to them. So the white stuff is the existing 339 timestamp format that we all know and love, with the date, the T, and the time, and then a numerical offset if desired. This is, of course, inspired by ISO 8601. And what sedate does is providing a way to add hints to that. These are these bracketed things that are added as suffixes to a 339 date string, and that includes time zone hints. So you can say that those -08 there actually are America, Los Angeles. So if some politician gets the idea that the summertime daylight savings time needs to be extended to December, you can react to that, because no, this is an American time and not a Canadian time or whatever. And the other thing in the brackets, UCA equals Hebrew, is a more general extension mechanism. In this case, UCA means a Unicode calendar. The Unicode project collects certain localization information, certain types of that, and they have calendar formats. So this would be an indication that the date is expressed in Gregorian time, because that's what RFC 339 does, but maybe is best shown to the user as a date in the Hebrew calendar. So this is the work that sedate has been working on, and it seems to me that sedate is now converging. I think the last big problem was solved in the meeting on Monday. So we might add this information to the time tag definition. And since the time tag is designed to be infinitely extensible, this was really easy. So we just defined two new keys, -10 and -11, and actually another copy of them, +10 and +11, for critical information. And there you can put your time zone hint and your extension suffix. So I quickly wrote this up when the sedate meeting was done, and submitted this as time tag -01. So that's a pretty straightforward, obvious thing to do. And the only reason why we could decide not wanting to do that is that this might be overloading the time tag in some way. But since this is maybe not trying to be the kitchen sink, but pretty acceptive, how do you say that? Pretty responsive to people trying to add information to timestamps, that should be okay, I think. However, sedate also has certain limits in which it operates because of the way it is chartered. And it is chartered really not to leave what 3339 can do. So for instance, sedate is not going to have other time scales besides UTC. They have time zones, but not time scales like TAI or Leapsmear UTC or all the stuff that is floating around out there. But the time tag long has had that. So we are not limited to that, but sedate is limited to that. So one question that came up was floating time, which means a timestamp that actually is in local time without telling you how the local time relates to UTC. And we already have one such tag, the tag 100, the date tag. That is a zoneless tag. It doesn't tell you your date, but not which time zone you were in when you experienced that date. And since we appear to be able to do that at the date level, we might as well do it at the time level. And Emil had some arguments that we actually should be doing that on the mailing list in the last couple of days. Yeah, so there's also a little issue with sedate that RFC 3339 added -0 as a numerical offset, and that's incompatible with ISO 8601. Yeah, we probably don't have to react to that issue because we don't even encode numerical offsets in time tag, which, by the way, is something that maybe people want to do, but I haven't found a use case for that yet. So I haven't seen a reason to put that in. Yeah, so the question really is, do we want our larger freedom to actually put something like floating times in? And the way we could do this is a little bit, well, it could be inspired by NTP version 5. The NTP version 5 people also want to put in floating times. And they can just use or they plan to use the timescale field for saying that. So they would have UTC and TAI and Leapsmear UTC and local time. And we could just do the same thing. So that would be something where we wouldn't have to invent something new, but could just import this from NTP. It's only one new value for the timescale attribute, but of course it has some pretty interesting ways in which the semantics of time tagged data changes. So this is the situation, and I would propose that we, with respect to sedate, we try to go for synchronized publication with them. So whenever their working group last call finishes, ours should be finished too. I mean, we don't have to do this precisely, but that should be the general target date. But on the other hand, we should also be watching what NTPv5 really does in terms of adding floating time, and maybe even adding their leaf smearing timescale as well. But we probably don't want to wait for their completion to actually publish this document. I mean, there will be many things happening in NTPv5, obviously, but we don't have to copy all of them. So that would be what I would consider the obvious plan. The other plan, of course, could be to say, well, yeah, there are some use cases for floating time, but these are not use cases for tag 1001 and should be done in a separate tag. So that would be an alternative plan. I haven't heard arguments for that yet, but if people feel that way, then we probably want to consider those arguments. So that's what I have to say about time tag. So if people have an opinion on that now, that would be good to hear, or on the mailing list. Ira.
Just wanted to reiterate what I said on the mailing list earlier in response to your question. NTPv5, the protocol spec, there isn't even a unified spec to be called for adoption. The requirements and use cases have only just been adopted after a long period. So I consider that NTPv5 as an RFC or even as a late stage stable internet draft is a year and a half away on that order. So you certainly you can watch it, but I don't think you want to wait that long to adopt time tags.
Good. So I think what you're saying is in sync with what I'm proposing on this slide.
Very much so. And a separate tag is a fine solution at some time in the future. I don't, we don't need to add it because there are NTPv5 use cases or other use cases, unless somebody comes forward and says, we really need it in the general case.
Good. Okay, nobody else speaks up. Christian?
Any other comments
Christian
about
Amses
time
with,
tag? Go ahead,
Christian Amses with chair hat off. So just for clarification, even if we went with this document as it is now, there is nothing that would stop the later addition of the floating time through additional keys at the same tag, right?
No. Yes, you're right. There's nothing that would stop us from doing that. But we could do it now. So maybe it's just easier to do it now. Okay, I think we can take that one to the list. The next one is CBOR Pact, and that I think has taken a pretty surprising turn. We have actually managed to make this quite a bit simpler than I thought it would turn out to be. So we now have this function tag concept. So we actually even have an extension point in the pact mechanism. We have ongoing implementation work. We probably want to have at least one implementation that actually implements the current draft before we go forward. I think we will have to do a second working group call, but that's for the chairs to decide. And
yes, I think that's correct.
So the one thing that came up in discussions of other tag activities is that we are doing a little bit of a sleight of hand here by just saying all those tags that we defined in pact can be used in place of the data they stand for. And what we probably have to remember is that 8949 defines tag validity in such a way that a tag can define the shape, the structure of a valid tag content. So I can say this tag is only valid if the tag content is an array or is this or that. So we have a top-down control. Every tag can talk about their content, and that information is even recorded in the tag registry, but a tag cannot really control validity upwards. So a tag is a tag, and if an outer tag has been defined at a time when this inner tag maybe wasn't defined yet, there's essentially no way for the outer tag to make use of the fact that this inner tag maybe fits extremely well in the outer tag, because the inner tag cannot make this kind of information available. But that is a problem because tags often are, the role of a tag often is to define data that actually stand in for other data. And we currently have no way to record this intention. And we actually had this problem already in 8746 in the tagged arrays, but we kind of glossed over it. 8746 is a collection of some 25 tags, some of which create data structures that really are arrays, and some of which operate on data structures that really are arrays. And so we defined the term typed array and use that term everywhere in this spec where an array is needed. But if we now came in and defined another tag, 26 tag, that has the same properties as a typed array, we cannot do this because 8746 just enumerates those 25 tags, and that is a complete list of what can be the tag content for such a tag. And the same problem, of course, happens with CBOR packed. Now a reference tag stands in for the reference data, but a tag that has a reference tag as tag content, or has a data structure that it wants to control, that has a reference tag in a position that it wants to control, that tag has no way to make way for using this reference tag there. So an implementation that has a tag validator that operates before unpacking will break. Will find a reference tag in a place where it didn't expect the reference tag, and will mark this as invalid. Brendan?
I think that there's a logical flaw here. Your tag validator must have already validated the outer CBOR packed tag for it to ever encounter a reference tag. And if it's done that, and it's recognized that tag, and it's been able to validate that tag, then it knows full well that it's going to encounter references inside it.
Yes.
So there is no flaw.
Well, you say it knows that it has encountered a reference tag. It may not know what the reference tag is.
No, it's encountered the outer CBOR packed tag, the one that defines the rump array.
Yes.
It must have encountered that, or it can't have encountered a reference tag.
Not necessarily.
How do you end up with a reference tag that's not inside a rump or an array of references?
The reference tag might be referencing to a table that has been set up as part of the content format, for example.
But then there's an implicit tag. You're still operating within the confines of a dictionary. You know it's there. And it's absolutely mandatory that you know it's there. So if your tag validator is dumb enough to go and encounter a CBOR packed tag and then give up when it encounters a reference, well, then you just have a terrible tag validator.
Yes, but one that actually is allowed by 8949. So this is really about legacy generic decoders. And a generic decoder usually has some tag processing in it. So for instance, my implementation, if it finds a tag 2 or tag 3, will actually generate a number, because in my implementation there is no limit to the size of a number. And what's going on with the audio here? Weird. And that means when it finds a tag 2 on top of something that, for instance, is a data compressor tag, which we haven't talked about, but that's actually what motivated this whole discussion. It will not be able to build a number out of the uncompressed data. It will just fail in this place, because the tag validity checking for tag 2 really is hard-coded in the generic decoder. So what this concept that these slides are about is actually doing is describing how this implementation of tag validity is actually deficient, and we create a new category of decoders that actually can deal with this situation. The old decoders, of course, stay valid CBOR decoders. They just won't be able to really work in packed environment or environment where we have new tagged arrays or data compression tags and so on and so on. Yeah, but Ben, you're right that there are some very specific assumptions here about how you actually reach this situation where things break. And one such assumption is that a table setup tag is not supported by the validity checker of a legacy decoder. So it will just present that table setup tag as is to the application.
But then it continues validation within that. Yeah.
Yeah.
Yeah. So that's the flaw, right?
Yeah.
You've parsed into a tag that defines the structure of its data in a very particular way, and you've just blithely ignored it and continued on validating tags anyway. Yeah. Okay. Fair enough. That sounds like a bad decision, but I guess that's what we've got.
Yeah, CBOR is really designed to make that possible. So the idea was to share the duties of tag validation or tag processing between generic decoders and applications. So when a generic decoder finds something it doesn't understand, it just hands it to the application. And if it finds something that it thinks it does understand, it actually may blow up in a place where it shouldn't blow up.
Yeah, no, I appreciate that. Okay, thanks.
But that's a very good observation, and we probably need to make this a little bit more explicit. Anyway, so what the new draft of PACT that I did right before the IETF, well, too late in any case, does is define a concept of tag equivalence, where a tag not only controls what is inside it, but also can say what it actually looks like from the point of the tag validity of an enclosing tag. So a typed array tag, for instance, could really say, hey, I'm an array, and everything that actually takes an array is supposed to be able to take a typed array as well. So of course that doesn't work when typed arrays are not implemented, but as soon as they are implemented, they can go into places that take arrays. So for instance, a data compression tag can stand in for a byte string, a new typed array tag can stand in for a CBOR array. What tag cannot do is stand in for something else that is not the same domain. So for instance, we have the tag for, which gives you a floating point number, mantissa and exponent. And we have 264, which also gives you a floating point number, but with an extended range of the exponent. And that's never something that you could handle with tag equivalence, because if the tag generates structure that would be surprising for the environment, it cannot just say, I will only ever give data to you that you know how to handle. So that's a limitation of this concept. And if we want to make tags generic between 4 and 264, we probably have to invent something else. Anyway, this is written up. And I believe this is pretty much a mandatory component of standardizing CBOR Pact. Christian has pointed out that this probably needs some caveats, because people shouldn't use this mechanism to build overly elaborate type systems that do weird things with data going on in there. So there is a little bit of text that provides caveats. Maybe we want to add some more caveats. And now the question is, how do we handle this? We could just standardize as part of the CBOR specification. This is the smallest number of documents, the smallest editorial effort. Yeah, I just ran through a very interesting case where people had really big problems with defining a data structure together with a new tag in one document. So the problem details the document over in core that raised some eyebrows because it defines a tag. And yeah, so maybe there are arguments to put it into separate documents, but my plan would be to not to anticipate them, but just to wait whether they actually come, and do this in the CBOR Pact specification. And then the question, of course, is, does this get an updates tag? Does it do an update to 8949, which of course is interesting? Proposed standard specification updating an internet standard specification. I have no idea how that works or whether that's a problem at all. Or we could simply not say that it updates it, which would be a little bit of a lie, but maybe a little bit of a white lie. So I don't have a strong opinion on that. Yeah, again, we could put it into a separate document. And then we have a little bit of an open issue here with the question, how do you actually express tag equivalence in CDDL? Because CDDL doesn't currently allow you to do that. It has exactly the same structural approach that CBOR had in 7049, and then we kept for 8949. So we will have to invent something to be able to express these things as well. But I'm not proposing to wait with CBOR Pact until we have invented that new CDDL, but this should be a separate effort, I think. Any comments on this plan? Ira?
I don't know that it's a comment, but it's a question for Barry or someone with deep experience of process. I thought a proposed standard could not update a full standard. Is that not true?
Well, I haven't investigated that. So let's find out.
So I didn't quite get Ira's question.
If I have a full standard, an internet standard 8949, and I have CBOR Pact and I published it in a later RFC, and I say it updates 8949 in a way that's rather, that's maybe stretching a point. In any case, is a proposed standard allowed to update an internet standard?
Yes, absolutely.
Oh.
What effect that has depends on what the update is, but I will give you more extreme situation. RFC 5321 is the current SMTP standard. It's at draft standard level, and it obsoleted RFC 821, which was full standard. So, all that kind of stuff happens. In the case of an updates, I would say that the new feature that the updated creates is at the proposed standard level, and the rest of the protocol remains at the full standard level. But yeah, that's fine. If that's the right thing to do, then that's what we do.
Reason for my question was I agreed with Karsten. I don't like saying don't update, that is, don't admit the fact that it alters 8949.
Yeah, no, absolutely. If it turns out that we made a mistake in an internet standard level document, we need to correct the mistake and put that back through the standards track starting at proposed. Absolutely.
Thank you.
Okay, if we're done with this item, I would quickly like to go to the next one, which is RFC 9254, which is standard defined by the core working group. What the core working group does is provide a form of concise web access to constrained devices. And when you provide some form of constrained web access, you probably also want to support management. So in 2013, we actually started thinking about how to integrate SNMP into the core environment. And shortly after that, it became clear that we really didn't want to implement SNMP here, but integrate Yang. So we started an activity that did that. And at some point, we found that the best way to do this would be to encode the Yang data not in XML, which is the original way of encoding it, or in JSON, but in CBOR. So that's how the core working group got to do the Yang CBOR document. And this is, of course, pretty interesting because with the publication of Yang CBOR, we now have a way to provide Yang defined data in CBOR, or you can put it the other way around. We have a way to define CBOR data using Yang. And one example for that is the constrained voucher that Anima is defining for Brewski onboarding. That is actually a Yang defined data structure that is now encoded in CBOR. And what we did when we did this, we didn't try to compress all the XML wordiness. So for instance, IP addresses or date time values are still text strings when you have defined them that way at the Yang level. Yang CBOR doesn't change that. But it has one significant performance perk, and that is all the Yang names, the names for the various items in the structure, which are text strings in Yang XML and Yang JSON, can be replaced by pure integers. And using data coding, this usually is very, very efficient because typically when you use one name inside the data structure, you probably use names that are close to that. And the allocation mechanism that is still being defined in the draft that is still in the ISG that tries to make sure that those data are typically relatively small. Anyway, we have a new tool in our toolkit. So when we see CBOR as a useful way to structure data, to represent data that is being interchanged, but maybe the group that is doing that is working on that, is more familiar with Yang or doesn't like CDDL for any reason, we may want to use Yang. And that, of course, opens a little bit the question, how do we make sure that these two parts of the CBOR ecosystem stay on good terms with each other over time? So that's a pretty complicated question, but I think in the future, when we do something on the CDDL side, we probably will have one look at the Yang side and see, oh, how are they doing things? And are we doing something stupid here by making it harder to combine CDDL-defined data with Yang-defined data or not? And actually, that has already happened. The way CDDL uses regular expressions has been aligned with the way Yang uses them. So we already have done that a little bit, but I think it's now obvious that we want to look into this some more. So Yang is a pretty complicated language. You can do a lot in that language. You can express co-occurrence constraints using XPath, which is the Turing equivalent language. So you may not always have the right level of complexity in mind when you do Yang, but when you do a really complicated management information-based standard, then maybe Yang is a better way to do this. So I just wanted to point out that this is something that will inform our CDDL development in the future, and we will certainly always have in mind that there's this other thing there that we want to make sure that we don't do stupid things. Good. So this is my little preliminary for the CDDL2 discussion. So just as a reminder, what the CBOR working group does, we have this CBOR format, which is stable. We are not currently changing anything there, but we have an extension point, which is the tag ecosystem. So we have to think about good ways to move the tag ecosystem forward, which is mostly done by the users of CBOR, but sometimes we generate some highly reusable shared tags. And the other item on the CBOR working group plate is CDDL, which was standardized as a 1.0, and with a strong understanding that we would want to develop this further, and that's the CDDL 2.0 discussion. CDDL defines one extension point, the control operator. So whenever we want to do something, one question is, can we do this with a control operator? And it turns out we could do much more with a control operator than we originally thought. So for instance, we have RFC 9165, which is really CDDL 1.1, because it makes some significant additions, but using the existing extension point. So it's not a new version of CDDL at all. It just provides additional functionality through this extension point. And that's in particular the ABNF support and the .feature support. There are also some other places where this group can do things. For instance, when we did CBOR, we defined diagnostic notation because we thought it was important to be able to put CBOR on a whiteboard. And well, CDDL is great on a whiteboard, but when you have tools that need to interchange CDDL these tools would need to have pretty printers and parsers for CDDL, and maybe it's just easier to just interchange JSON, and therefore, well, there is what you see on the right side of this slide is the entirety of the definition of the JSON grammar for CDDL. So if you want to interchange CDDL as JSON, this is the document you may want to look at. So that's something where we might want to do work, but I'm not proposing anything concrete at this point in time. So the actual CDDL 2.0 work is work where we need to go beyond the CDDL syntax we have defined in 1.0, and we identified annotation and composition as the highest priorities. Let's talk about composition. That's where we want to build a CDDL specification from multiple files, possibly files that come out of a library, so we don't have to do all this cut and paste stuff that we have to do today to actually build our CDDL specification. So there should be something like an export interface from a library file into some other specification using the library, and an import interface so that a CDDL spec can get some definitions from another spec. And of course, we need some naming conventions or mechanisms to do this. So the whole namespacing issue, I gloss over that because I'm already over time. Sorry. We also had the discussion how to do alternatives, so writing one specification that can actually generate different structures depending on some parameter. In RFC 8428 in CNML, we actually used some lexical mechanisms where we told people combine the CDDL in figure 5 with that in figure 7, and you can do JSON, and combine 5 and 6, and you can do CBOR. We now have .feature to do this a bit on a more semantic level. And maybe at some point we can extend this in some way that you actually can translate between the alternatives, but translation is not currently something that CDDL supports at all. The other thing that maybe is even more important than coming up with a good syntax for this is doing automation. So making libraries available from existing sources like RFCs and internet drafts, IANA registries, non-IETF sources, 3GPP, and so on, and being able to trigger this automation from a CDDL spec. So one way to do this is actually to come up with a syntax that is CDDL1 compatible. So a CDDL1 file is a CDDL2 file, and on the other way around, a CDDL2 file can be parsed by a CDDL1 processor, and it can still do useful things. It cannot use all the functionality, but it can do useful things. And that's something that helps, of course, with an ecosystem where we now have multiple implementations and all want to take them along for the ride to CDDL2. So we would put some of the functionality of CDDL2 in comments or control operators, or maybe rules that are otherwise unused. And one way of trying to do this is to really put all of this composition functionality into something that works a bit like a preprocessor. Maybe not like C's C preprocessor, maybe a little bit more, keeping in mind that there is a certain structure that we want to generate. But we could put all this referencing and automation and so on into something that looks like comments and is actually interpreted by the pre-processor. So that actually could be useful for ABNF as well, because CDL is so close to ABNF. Whatever we would do in such a preprocessor would probably immediately be applicable to ABNF as well. Yeah, so this is a potential objective for the composition. The annotation aspect really is about going beyond Kernighan's car. Kernighan's car is a car where you only have one indicator light, which when it's off says everything is okay, and if when it's on, it says something is wrong. And that's your traditional validator that validates an instance against a schema and tells you that's wrong or that's right. And the idea is that annotation can give you back more information. But right now, what we have in CDDL implementations are annotators that don't get the benefit of information provided by the spec writers. So the spec writers cannot say whether a particular rule has only been created to minimize the line length in the specification or something. So these are not rules that are carrying semantic information that an application would be interested in. And we only have dot feature for carrying information beyond rule names. And these rule names also are not related to the real world, so we cannot use RDF names as rule names and so on. So this is all related to the post-schema validation instance thing. I showed this slide on IETF112, so I'm going to go through this very quickly. But basically, the idea is that if you do a validation process, you get an enriched and augmented version of the instance. And of course, what is the data model for that enriched version? And can we define JSON and CBOR diag and YAML and CBOR for that? So that would be an important addition to the CDDL ecosystem. So you can take the validator output and feed it into some application that, for instance, gives you a specific interpretation of what you just validated. So the question is, when do we get all this? And in IETF 112, I had some pretty optimistic timelines, and I think these are a little bit more realistic ones. So for IETF 115, we should have a prototype of this composition engine, which might be a preprocessor if we're lucky, and maybe some first elements of the annotation semantics, for instance, just a definition of the post-schema validation instance. And that would allow us to look at this in IETF 115 and decide which of the functionality that has been prototyped do we actually want to go forward with, and which should be discarded because it's too complicated or too dangerous or too much of a problem for interoperability. And then in 116, we could try to make sure that we actually have a spec for that is technically complete and agrees with the implementations that exist. And then we could maybe do some document splits or decide how exactly this should be published. But we should have something that is reasonably stable so implementers can actually start playing with this. And there's also a longer term objective, which is really increasing the integration with IANA. There's so much data in the IANA registries that we currently have to manually extract to use that in specifications. And like we had with core SID, We had a multi-year discussion with IANA that finally came up with a mechanism that we could all agree on. We could discuss with IANA how we actually get the web access interfaces we need well defined. Maybe even be able to tell IANA how much additional load we are generating by people using CDDL, and maybe even define some rules for future registries so they become automation friendly. Yeah, and I already talked about the interpretation between Yang and CDDL. So let me go back to this. So this is a bit, of course, also a question to implementers. What components, what toolkit elements would they like to see to best be able to participate in this development? So I think Brian.
Yes, hello, Brian Sievers. Speaking as somebody who's done some CDL development in DTN RFCs, the composition aspect is something that would be very helpful because we're starting down the road of building up libraries, and as you said, copying and pasting or concatenating things runs quickly into limits of scale.
So could I use you as a source of little snippets that we could use to understand our use cases?
Definitely.
Great.
Christian Anders, as a from the floor, doing things via comments sounds really scary to me, and I wonder whether it's not a better approach, or at least an approach we should consider, to introduce new syntax elements, which would make the documents incompatible with CDDL1, but at the same time define possibly very simple rules how to remove all that new stuff and receive the equivalent CDDL1 document that one would have obtained if we went for with comments, so that as a user I don't have to tread carefully around what possibly the new language might interpret.
Brendan, you have an opinion on that?
Yeah, so I ended up needing an extra control operator in CDDL specifically to represent sequences that are key value pairs but not encoded as a map, encoded as an array instead. And the solution I eventually settled on was to not do anything at all in the CDDL, leave it exactly as it is, and then use an external document to annotate which paths into the CDDL had this kind of information in them. That seemed to be the simplest thing at this stage. And I wonder exactly how much of this is actually something that belongs in CDDL itself versus something that honestly belongs in an external annotation.
Is any of that available for people to look at?
Definitely, it's still very much in a prototype stage, and I don't have it ready yet. Ultimately, the goal of that project was to produce an automated suit parser generator. That hopefully will come at some point, but it's not quite there yet.
Yeah, I think I would like to see how you actually reached into the CDDA file and annotated some additional functionality in there. That would be interesting. Lawrence.
It's closer to the microphone. Or... We are switching on the floor mic. We are having trouble switching on the floor mic. Yeah, just. Does this mic work?
Yeah.
All right. Let's bring that one down here. So this was a comment on EAT's use of CBOR for JSON and EAT's use of CDDL for CBOR and JSON. So I did a lot of work with that, where I have CDDL that can express data structures that are kind of encoded both in JSON and CBOR, and I definitely ran into a lot of limitations with dot feature. I don't know if anybody else has tried this, but there was at some point I just had to give up on dot feature for it, and that was where I was embedding CBOR in JSON and JSON in CBOR, and that really that was too much for it. I also found that the CDDL tool, the diagnostic output or the error output from the CDDL tool with the use of dot feature to distinguish JSON from CBOR was hard to work with. Yes, that's my comment.
Yeah, I think the embedding point is really, really important. That hasn't been addressed yet. Good point.
What shall I do with
Okay,
mine?
just set the mic on the table. So, okay, and we are out of time. So let's, if we need to wrap things up, let's do it quickly. Karsten?
Yeah, I got some pretty good feedback now, and we probably have to pursue this feedback on the list. In particular, I would like to know what Lawrence's embedding situations were, and how we maybe possibly can address those.
Okay, so we have that. The other item we had, Christian, you had a tag registry item. We have our next interim call will be on the 24th of August. And I guess we'll just put those last two things on the agenda for that.
Yep, let's do it that way.
Okay. So everybody, thank you for coming. And thank you especially for Marco for taking notes. And those of you for whom it's after midnight, thank you for staying up late. And we'll see you all on the 24th of August and on the mailing list.
Thanks, everyone. See
Cool.
you.
So I'll start looking at the